A few little notes. If you have questions, just raise your hand. The light's a little bit bright, so you might have to wave around a little bit, but I'm happy to take them. We'll publish the slides right after the presentation, so don't take furious notes. They'll all be up. And there is little links at the bottom right. So whenever you hear me say something like, this is a number that's totally true, or here's a thing that I attest to be absolutely correct, there's a little link there that will actually point to that. All right. So what did I do before I got here? I used to run the RIPE database, which is where you go to get IP space. So if you ever got an IP address or on the internet, anybody here on the internet? Just me? OK, cool. You're welcome. And after that, I worked for a company called Canonical. Who here uses Ubuntu on their servers? That should be everyone. Really? Who here uses Red Hat on their servers? Ooh, tough crowd. OK, so I was there for the 10.04 and 10.10 release. 10.04 was the first long-term support release that we did for EC2. It's probably still the best operating system, at least in my opinion, for EC2. It's definitely the most popular one. And I'm assuming you're a bunch of Java guys, given that you're using Red Hat. And we do apologize for the state of Java and Ubuntu, one of the little things we didn't quite get fixed. And so about 4 years ago, I joined a company called Krux. And what we do, or the way that we talk about it, I should say, is think of it as Google Analytics, but for audience rather than traffic. Or the way I explained it to my mom is that thing that Netflix does to figure out what you want to watch, and that thing that Amazon does to figure out what you want to buy. We do that for everybody else. So our customers are guys like New York Times, Wall Street Journal, and so on. And we do that with a very strong focus on consumer data privacy. So the idea is that you interact with these websites, they want to customize your content, and we are their data storage. And so here's a list of our customers. It turns out that this is a pretty common issue for just about anybody who wants to tailor content online. Anybody that has user interaction wants to give them more of what they want, so they keep coming back. And whether that's content, advertising, it doesn't really matter. And data privacy, well, you've all been reading the news, I'm sure, is a pretty hot-button topic, and it's something that we care about a lot. So we're almost the de facto provider in Europe for this type of solution because we are so strongly focused on data privacy, keeping your data safe from anybody who wants to do something bad with it. So as a result of all these customers, we get 1 or more calls per page view for every one of their websites from all over the world. And for every one of those websites, and some of them are even devices like Roku, we're on the critical path for site delivery. So whenever we have outages, that would be actually pretty bad. And so I like to put that into perspective a bit. Now, let me prefix this by saying it's a bit of apples and oranges comparison. But it does give some color to the amount of traffic, the amount of things we see. So Twitter does about 9,000 tweets per second on average. They do a bit more work on their incoming tweets than we do on our incoming data. I think the Twitter record is 33,000 tweets per second, 2013, New Year's. Everybody in Japan was tweeting like crazy. And our daily trough is 36K. So the peak of tweets ever versus our trough kind of goes like that. In total, we do about 120,000 external requests per second. And that's our average. So you compare that to Facebook. They do about 140,000 just Facebook Messengers requests per second. So there's that. But in terms of reach, we see about 4 times the amount of users that Wikipedia does. They're about 500 million. We're about 2 billion. And that means that we process about 50 terabytes of raw data per day. And it's about 2 billion key data store. So it's a fairly massive set of data. When you process that much data for this many users and that many clients, even a small decision can have a really, really big impact. Like, 0.5% of our users is a lot. We would be inconveniencing very many people if we mess up something in that last little percentile. And so when we make a change in, say, service performance, and it changes the profile, we definitely want to know what happened. And if we're making a design decision based on what we had before, we want to use those numbers to matter and to be very well informed. And we'll do our cost-benefit analysis based on that data as well. And we want to be able to go really, really deep. And so to do that, we collect, at this point, about 1.5 million unique metrics every second. And that is a number that doubled, as you see from the graph going up, over the last 9 months. And so we just keep expecting that to go to the right as we grow. So the things I want to cover today is how can you set up a system that can also capture all the metrics you would ever want, and that can be useful to you, and more importantly, how you can make them actionable. It's one thing to collect 1.5 million metrics a second. It's a whole different story to actually make them useful and insightful. I'll talk a little bit about the visualization of the data as well, but I found that the most effective visualizations usually are domain-specific for you. So I'll show a few tools, but there are literally dozens and dozens of visualization tools, so please feel free to explore. The same can be said for monitoring as well. Most companies probably already have a monitoring system in place. I know we're being recorded, so do it with a small hand. Anybody here has a website they're proud of that doesn't use any monitoring whatsoever? Wow, one person. Now I understand why you didn't want to be on camera. I totally get it now.
It's my dad's blog and he's dead.
Oh, wow, okay. So cheers to your dad. So I would argue most of you already have a monitoring system in place, and if you don't, you probably have very different constraints or additional constraints to just how many metrics per second it can take. But again, I'll point out a few, but feel free to explore. So why do I care about visualization? Computers can do a lot for you, but human brain is better at recognizing shapes and patterns than any computer is currently. It's definitely cheaper to do. So just looking at data points when something's wrong is probably not good enough. If you have a good visualization, it'll help you understand if it always behaved like this, or if this is different, or if something changed now compared to some time ago, or if there's any types of really strong correlations. Sometimes just being able to look at the shape is just as important as the data itself. We have a type of event that we see, and when we saw it for the first time, it was kind of interesting. It went like this, traffic like this, and it spiked up and then tapered off over a period of about 30 minutes, and it went up about 30 to 40%, spike and down. And so when we were looking at the graph, like, what happened? And the answer is, Kate had a baby. All right, but so we now see enough of the internet to actually see the shape do this. And this is a very predictive shape for us for a news event. So when the Boston bombing happened, that happened. And many more of these events show this particular shape. And so you could ask a computer to tell you that it's a news event going on, but our eyes immediately recognize this shape. So most teams, especially in the operations world, use metrics to diagnose outages or maybe troubleshoot their systems. And even though it's a very valuable tool to do exactly that, I would also argue it is really good for things like understanding trends over time, for capacity planning, for performance tuning, cost predictions and optimizations, even A/B testing, or even just keeping track of your company's KPIs. So I would say metrics aren't just for operators, they're for everyone, and you should collect them for everyone, and you should display them for everyone. They can really help your company make better decisions, not just the engineers, but also the business units. And they can even avoid some investments. Here's our bottom line. This is a graph from actually one of our board presentations. I had to remove the axes numbers because of proprietary information, but the shape holds. By making smart usage of the data that we collected, we were able to grow about 10x using the same cost profile. We figured out where to optimize, where the waste was, and where we weren't getting the best bang for our buck. And these are our costs across the board. So this is hosting, storage, processing, with CDN, DNS, all of those. Our revenue tracks the requests per second and unique users we see. So that means 10 times the revenue, means 10 times the users, 10 times the page views. And so using the data we had available, we made better decisions, and we probably averted at least one round of funding by not burning through our capital. So what made this work? How do we build this pool of metrics? In the end, it was just one key feature of all the things we try to implement. We made it really, really easy to use. That's it. You can't look at metrics that you don't have. And if adding metrics is hard, nobody's going to do it. Now, of course, there's a few other extra characteristics that you'd be lucky to have. Things like a highly scalable store, something that's very cost effective, something that's easy to operate so you don't have to hire a guy to just manage your metrics store, something that's very easy to integrate with so your tooling can do it, something that's easy to introspect, something that's very configurable to your use cases, and even more importantly, if you want to measure everything, it should be very flexible on the inputs it takes. And so I'll try my best in this talk to cover all these points. But let's start with what makes sense to see. From all the metrics you'll be collecting, most of them you'll probably only need when you're making a very specific decision or when you're trying to answer a very specific question. So what's the thing that you should put on your internal dashboards? What's the thing that helps you with the shape? The most important part is, in my opinion, to have a high-level overview of your KPIs. And that, in turn, will let you drill down as far as you need to go. If you know your high-level metrics, you can go from there. What those are probably different from company to company, and your company is not like my company. But despite these 1.5 million unique metrics, it turns out we only care about two things at the high level: latency and error rates. That tells the story right there. In the end, all we care about is that our customers have a good experience and that they don't have to wait any longer for content than necessary. So as an example, I'll show you the one dashboard that we build for every service we have. So this is a list of request and error rates of a particular service that we have. We run dozens and dozens of microservices, as I'm sure most of you do as well, and I just picked one at random. All of them have the same type of characteristics. They serve some sort of request in some sort of time. So the first thing we'll want to see is like, well, how many requests and how many errors? So this is a cluster aggregate view. It shows the aggregated QPS across all of them. This is a 2-day window, and so it has the usual pattern of requests. It's this wavy pattern. And good for us, the red line at the bottom is flat. There are no errors, is what you want to see. That's your baseline right there. Next, the response time for the cluster. Because we run many machines with this service, you should track the worst 95th percentile and the worst 99th percentile. Because if you have, say, 100 machines running a service and 2 of them are particularly bad, the other ones will mask by giving you an average. So as long as you plot the worst 95th and the worst 99th, you can see how your service is behaving. Anybody who just graphs average response time is telling me they do not care about half of their users, which in our case is 1 billion users, which would be a little bit mean not to care about. So we go a little higher than that. So there is a little spike in latency, a little bit off to the center. We don't know why yet, but at least now we have insight that it happened. And so the why is a big deal. One of the reasons that your latency or error rates might be going up is because you changed something in your environment. One such thing, the obvious thing, would be a code deploy. And something that we do quite a lot is run MapReduce jobs that update databases, and those might be flushing caches. So if the cache is empty, we might get a slightly higher response rate. So we add these types of events to all of our graphs. We graph them as a vertical line to show when they happen. And the brown line is a deploy line. The pink line is when MapReduce starts. So if you see latency shoot up right after, well, it's easy to correlate. It used to be 50 milliseconds. Now it's 250 milliseconds. A deploy happened. One of the devs just didn't test their code properly, or didn't test it under load, or there's some pathological case in there. As you're developing your services, you probably spend some time benchmarking them and have a good idea of their capacity. Or let me rephrase it. If you're not doing that, I strongly suggest you start benchmarking your tools and make sure that you know their capacity. In our case, we set the safe capacity to about 2/3 of the maximum throughput. That gives us the flexibility that when somebody does do a code deploy and the throughput goes down, the app doesn't actually slow down. And also, if nodes in the cluster start failing because Amazon makes a mistake or something else bad happens, we have some buffer before we have to worry. And so this just helps us visualize what we understand our capacity to be. So we draw this horizontal line at 2/3 of the max capacity multiplied by the amount of active nodes we have. And then the total thing looks like this. So we have one of these for every component that we run. And this is the health dashboard that in one glance tells us whether everything is running the way we expected, or maybe trending in the wrong direction. We have more granular dashboards for every service that help us troubleshoot very common items and common issues. But this single overview is the thing that we put up. It's the thing that we look at. So what should we capture? We would actually argue that you should capture everything you can get your grubby little paws on. Because metrics can help you make good decisions, diagnose issues, and correlate events. So you should encourage metric capturing as much as you can. That helps you do the drill downs, that help you look further. That 99th percentile spike that we saw, well, we knew it happened, but if I didn't collect any other metrics, I would have nothing left to look at other than go spelunking through all the logs. And if you have to do that, you've already lost. So when you see that app time response time spike, it could be a slow disk, it could be saturated network, swapping, CPU contention, any number of factors. But unless you're proactively capturing those metrics, you won't know. And the reason you should capture them up front is you'll lose a lot of time gathering those metrics that you could have spent fixing the problem. When you know the 99th percentile goes up, and you then start instrumenting your code, you're now wasting time. It's 99% is up. A lot of users are having bad experience, and you're troubleshooting even getting the metrics. even worse, you could be introducing new bugs or new slowness, and you wouldn't be able to compare it to data before. So if the disk A time comes in at 20 milliseconds, is that good or bad? Did it used to be 20 milliseconds? Is that a problem? I don't know. I didn't have the metrics from before. So make it easy to capture and capture everything. All right. So this stops the evangelical part about why you should care and how much you should capture, and we'll get into how you actually do it. So how do you build an infrastructure that lets you collect this many metrics without breaking the bank? We run a trifecta of statsd, collectd, and Graphite. And here's how they work together. On every individual node, we run an instance of statsd and an instance of collectd. Collectd gathers the system data by running some plugins and passes the metrics on to statsd. Statsd gets those statistics, does a bit of basic math, and sends it off to Graphite for storage and for interaction. And we'll go into all of these components separately. Anybody here hasn't heard of collectd? Okay, just a handful of you. Go through it quickly for the folks watching remotely. It's an open source monitoring tool. It has a whole pile of plugins that come with it by default, and it'll be things like looking at CPU usage, disk, and so on. But besides triggering alerts on that, you can also collect the system stats as well as running your own plugins. So for systems like Redis and Cassandra and so on, which expose an admin interface that you can interrogate, we drop little collectd scripts in that interrogate that admin interface and then send the stats off. So that's how we get a complete view of the system. We basically use collectd as a scheduler, and we interact with statsd from there. So on to statsd. Who's using statsd in production right now? Ah, my cool people, awesome. So statsd for us is the core of all of our metrics collecting setup. It's a pretty lightweight daemon. It's written in Node.js, and it listens on UDP. Statsd will accept a metric and a value and does some basic math on that, and then send it off to a backend. By default, that backend is Graphite, but you can get other options like Zirconis or Zabbix and so on. We run it on localhost on every node. The reason for that is that localhost UDP is guaranteed delivery. You still have all the benefits of UDP, which is fire and forget, but it will always be delivered. Or I should say, if you have a really high request rate, you might have to tune your kernel's UDP buffer to make sure it doesn't get overflown. But it's 120K by default. So if you go over that, you probably have bigger problems. And I should say, if you don't have localhost UDP deliver anymore, you probably have even bigger problems to not getting stats from localhost. Another benefit is that stats collection now scales horizontally with the host count. Because we run statsd on every individual node, it doesn't matter how many I spin up. The stats collection is fine. So I just have to worry about the receptor, Graphite. That's my only scaling option left. All right, so how do you stay sane when you use statsd? Pick a naming scheme and stick to it. It's the only thing that matters. It just has to be consistent. The reason for that is exploring in Graphite becomes much, much easier if you have a consistent naming scheme. It means creating graphs is much easier because it's very predictable. And it makes automated roll-ups of stats really, really simple, which I'll show in the next slide. So here's what we picked. Feel free to copy that or come up with your own one. It doesn't really matter. The important part is consistency. So what we do is we separate our stats by environment, prod, staging, dev, and so on, to make sure that if you have this box in development that is doing weird testy stuff that comes up with a very high 99th percentile because tracing and debugging is on, it doesn't skew our graphs and make think anything is bad. We also suffix every stat with the host name it came from, so we can get host-specific stats. If you want to know where the problem came from, if you graph your worst 99th percentile, you can find the ones that actually trend the highest and go look at them. That also means that, again, the aggregator setup is a lot easier because we know the last little bit is the host name, so we just chop off the last bit and then aggregate like that. We set the prefix to cluster name as well, so we can dig down by, say, the API services in Ashburn or the www servers in Dublin. The nice part is also because we run statsd on localhost, we know the host name already when we're sending it because it's part of the statsd configuration. And so this is what you would put in your actual statsd config.js. The prefix and the suffix, like we said before, disable the legacy namespace, which is a little bit weird. It's an odd default that should have just gone away. There was a crappy namespace before. Now there's a great namespace, but the crappy namespace is still the default, so turn that off. And make sure that you pick your percentages that you care about, that you want to roll up to explicitly. So we say 95th and 99th. You might want to have like 90th and 95th, whatever matters for you. There's some folks who actually add the 10th percentile as well to see their most optimistic response time. So it's going to be between these two bands. And you want to delete the idle stats. So when you once got a stat once, that statsd doesn't keep sending it even though nothing is there. That's good to keep your disks in Graphite in check.
So with that configuration, you're storing the data you use to troubleshoot on the node itself and then shipping only the data you need for your graphs to Graphite? Am I understanding that correctly?
The question is, do we store the data for the node itself on the node itself and then ship just the graphs to Graphite? No, this sends stats to Graphite using this scheme. So there's no local storage, it's stream processing. So it says, let's say that you send a stat that says foo is 1. It's a counter for 1. What this configuration does, it says, well, actually, the stat name is stats.prod.ww-dub.foo. Whatever the host name is, equals 1. So we have the prefix and the suffix there, so when they all get sent to Graphite, we can distinguish this node from another node, and from another cluster, and from another environment. Does that make sense?
Yeah, but I'm more interested in the percent threshold setting.
The percent threshold setting. Yeah, this means that only the 95th and the 99th percentile are being computed and sent off to Graphite by statsd. You could also ask statsd to compute the 50th percentile, or the 90th, or the 80th, or whatever you care about. Does that make sense? Cool. Thanks. Could you repeat the question, please?
The percentile value is computed from among all the nodes that send given metric value at given time.
If the percentile is computed from the nodes that send at the given time, yes, this is computed on localhost from the app that sends the stats, and it computes the 95th and the 99th and sends that off to Graphite for that host. All of our hosts have exactly the same configuration, so all of our hosts report in 95th and 99th. And we use Puppet to make sure that that's being done. All right, let's get on to Graphite. So we use Graphite for our backend metrics store. All the graphs you've seen so far came directly out of Graphite. It uses WhisperDB to store its metrics, which is very similar to RRD graph, so it's a round-robin database. It comes in with a built-in query composer and a graph creator, so you can do all your basic graphing like that. And it can also return the data as JSON, so you could do either your own analytics, your own graphs, or your own alerting based on top of that. And it's open source, which means it's free like speech, but not free as in beer. It is free as in beer. It's free. One major constraint to be aware of is that beyond very powerful wildcards, which Graphite does have, there's no really good search mechanism. Like, it'd be great if they would integrate Elasticsearch or something like that, but they don't. So you have wildcard expansion, and that's where it stops, which is why it's so important to pick a sane naming scheme and stick to it. The dots are record separators, and that's where the wildcards operate. So just pick a naming scheme, you'll be good. So how do we get to 1.5 million metrics from something this trivial? What we do is we run one Graphite instance per data center we are in. And that is to minimize the risk of network failure between the localhost statsd, which is running on each and every node that is doing work, and Graphite itself. If we would have to go transatlantic or across data centers, the odds of that traffic being dropped or backing up or there being a network partition or any type of failure is much higher. So we store locally. We could run a cluster of 2 or more of them if we wanted data duplication. We actually choose to aggressively back up instead, and we will accept that there's a gap of 5 or 10 minutes in case one of those nodes goes down and we need to spin it back up again. Every Graphite cluster uses its own MySQL and its own memcache. MySQL is for stored queries, so if you have graphs that you want to do over and over and over again, or you want to have user authentication, that goes in there. And memcache is for caching metric requests. So if you say, give me the last 2 days of data, and then you say, oh, give me the last day, that's a cached response, because you got 2 days worth of data, and now you're just asking for a subset, so that returns much faster than having to look them all up again. You should pick one Graphite to be your web UI. And contrary to what you might think, don't pick the Graphite closest to you. Pick the Graphite with the most data on it. And the way it works is all the Graphites store their data for their data center, and they stream it to the Graphite that has the UI on it, or the UI that you used. So the disk access and then streaming across the internet is slower than the rendering time. So just go to the one with the most data on it, and then it doesn't have to ask so much from its friends. There are a few things that you'll want to configure for your Graphite setup, and we'll go into those next. Number 1, data retention. In Graphite, you can define your own data retention periods. You can make it as granular or as crazy as you want. We played around with it quite a bit, and we actually picked this scheme, which is very straightforward. So for every metric we have, and I literally mean every metric we have, all 1.5 million of them, we say keep data for 10-second granularity for 6 hours. Because for the last period, I probably want to have a very narrow window and very granular things. The 10 seconds comes from the stats_t flush interval, which by default is 10 seconds, which we think is good. If you change the stats_t flush interval, change this interval as well. You want them to be the same so it rolls up the same. Then we keep 60-second granularity for 15 days. 15, not 14, because you don't want to accidentally cut off just at that end of the 14 days and have a weird little spike at the end. And then we do 600-second granularity for 5 years. The company's been around for 4.5 years, so I don't really know what happens after 5 years, but so far we seem to be good. I've not really had a need to go back to data 4 years ago. The x files factor equals 0 means that there's not a second copy of that metric on any other cluster. If you wanted more of them, run 2 graphites at x files factor to 1 or 2, and it'll start sending out copies. But as I mentioned before, we just do backups, we restore, and it's fine if the stats aren't there for a bit. That doesn't affect our users. If you use this scheme, you'll use about 3.3 megabytes per metric that you store, which we think is a pretty good trade-off between size and granularity. All right, let's talk aggregation. Lots of stuff on the slide. The only thing that really you need to pay attention to is the bold ones. So using the naming scheme that we used before, we tell Graphite's aggregator to aggregate stats on the server side. And this is a straight-up trade-off between CPU and IOPS. So for things that you want to look and aggregate all the time, let's say total requests per second to a certain service, aggregate them up front. You burn a little bit CPU, and it computes that metric for you, including all the derivatives like averages, sums, uppers, lowers, and so on, at the benefit of not having to do it at query time, of having to take those 100 hosts with those 100 data sets and then add them all together. So this just makes for a much snappier UI and making sure that you always have that one data point. So the first 2 lines are for running average and sum, so we don't have to do that computation when we make our graphs. And the second lines compute the upper and the lower metrics. So lower in this case would be like your best case scenario response times. And this is just for timers, so you should do the same thing for gauges and counters if you care. We tend to dive in per host only if there's something we feel that we need to dive deeper on. Like usually the aggregate stats tell us the story, but if we see that there's a 99% outlier that's really, really weird, we might look at the most deviant nodes and then start investigating from there. So this is what we usually look at. We usually look at the computed aggregates. So we talked about the good news. Let's talk about the bad news. The first thing you're going to run into when you scale Graphite is you'll run out of IOPS on your disk. So if anybody still runs with A-time on their disks, don't run with A-time on your disks. You don't care. And it's also a great bottleneck right there. So don't do that. And use SSD boxes. Like if you're not using SSDs for your Graphite, or as one of my friends told me the other day, SSDs, we use Fusion IO. Like they've gone one step beyond that just to get the IOPS out of it. Once you use that, it's going to be very hard to saturate the machine on IOPS. Your next problem is going to be CPU. All the daemons are written in Python, which unfortunately means that they're quite CPU hungry, even if they're doing their IO select busy loop. That means that they can block also when they're slow readers or slow writers on either end. So if one of your streams is just kind of slow, it's blocking that thread for a while. So make sure they run at least multiple of each type. The faster the CPU is in the box that you have, the better. If your trade-off is 4 CPUs that are really, really fast versus 8 CPUs that are much, much slower, I'd go with the 4 over the 8, hands down. In our case, we run this all inside of Amazon. And so we use their High-1 4x large boxes, which are their big boy boxes, lots of memory, many CPUs, and 2 terabytes of SSDs on them to run this on. And we run with 5 relays, 6 aggregators, and 6 cache nodes. So at about 1.2 million metrics per second, you're going to start running into CPU contention with this configuration on this particular box. At that point, you can't get a bigger box inside of Amazon. And the best next thing you can do is to split out your relays and your aggregators to different nodes. And you just keep the UI and the cache nodes, which are the things that take the final metric and store it on disk on your UI node. and that should comfortably get you to about 3 million metrics per second. If you get beyond that point, let me know how you fixed it, because I want to talk to you. While we went through this scaling exercise, we figured somebody would have solved this problem already for us, so we went and Googled, like, how do you scale Graphite at this point, and we found 3 very helpful blog posts written by us. So I'd like to find one of your blog posts soon. All right, so maybe you don't want to run Graphite. There's 2 other solutions that I'd recommend. If you're ready to host your metrics and your alerting, go with Serconis. Right now, this is the best visualization tool that I know of. It has custom graphs, it has heat maps, it has all kinds of features that Graphite doesn't have. It has advanced math on metrics, and it does alerting as well, which Graphite doesn't do. Graphite just does metrics. Ultimately, if you want to self-host, Zabbix is one of the leading open source monitoring solutions there. Both have a statsd output module that allows you to send metrics their way, and they're linked from the bottom if you want to go play with them. The real challenge with these solutions is to keep the price point reasonable, and we'll talk about that in a moment. So building custom dashboards, we pick something really, really straightforward. There's many, many different ways. Graphite has a built-in composer that lets you create dashboards. You can save those queries, and there's tons of third-party tools as well. We actually use Graphite.js, and it's a very, very thin jQuery wrapper. And what it lets you do is use variables and loop to create dashboards. And that is code reuse and consistency right there. And because all of our stats are named in this very consistent way, it's very easy to say for s in service do, and then you just draw them all out. What we really liked about it is that every developer that we've employed knows how to write basic JavaScript. So if they want to do a new service, be like, here you go. It's just JavaScript. Go build your dashboards. We host those dashboards as flat files in a GitHub repository, and then we push them to Amazon S3. And from there, they're accessible to everyone, and we display them on a bunch of TVs around the office so everybody can see what the normal is. The picture on the slide is actually our Graphite dashboard of Graphite. So you can kind of see how it's behaving. There is one slide on the left-hand side, third from the top, that's completely blank. That's drop metrics. It's meant to be blank. If there's a line on that slide, that's bad. So like I mentioned, there are tons of other front ends to Graphite. They're linked from the slide as well. There's a guy who did an in-depth review of like the top 30. And the one that's been standing out there, and I've been hearing a lot of good stuff about, is Grafana. So if you're starting from scratch, you might want to check out Grafana as well. So why pick all this instead of going fully hosted? Let's pick a few solutions and compare them. Amazon CloudWatch. We're based in Amazon. Why not use CloudWatch? It's provided. It's there. I don't have to do anything for it. An individual CloudWatch metric costs 50 cents per metric. So at 1 million metrics per second, which is actually less than I want to send, I'd be paying them $500,000 a month for my metrics. It's not OK. They would also only be at 1 minute resolution. My industry works in per second. Their apparently works per minute. Again, not OK. And they don't do composite graphs. So that's like 3 big things that makes that a no-no. Serconis, which I would argue is the best in breed right now, is at a bulk discount, 30 cents per metric. That's still $300,000 a month to pay for Serconis. Although you get tons of extra features. And I'm pretty sure if you start sending them 1 million metrics per second, they'll give you a much better rate than 30 cents. But still, it's hard to beat this. Our Graphite setup is less than $2,000 a month. So for over 1 million metrics, that's less than 1/5 of a penny per metric. Now, because Graphite does graphing and not alerting, not every metric requires alert. But hosted solutions have a very hard time telling the difference. If you're sending them a bunch of metrics, they expect that they have to alert on them. Or maybe that you would change your mind and want to alert on them, which means they have to do much more work and store them in very different ways to make them alertable, which raises the price point. But because Graphite exposes its data as JSON, you can build your alerting on top of it if you wanted to, and which we do for latency monitoring. Alternately, you could get the best of both worlds and forward all the metrics that you want to alert on to a system like Serconis and keep the rest of them just in Graphite for graphing and troubleshooting purposes. If you're going to do that, at least send the user-facing metrics like app response time and error rates to Serconis. Definitely worth it. Most importantly, and why we care about cost so much, aside from breaking the bank, it aligns incentives. We, as operators, want our developers to emit as many stats as possible. The more that you emit, the easier it is for us to see what's going on. The less time that we churn on trying to fix the problem, the less time you churn, it increases our velocity, it increases our confidence, it increases visibility, it reduces frustration. But if you feel constrained by the cost, that for every line that you write that says metric foo, and you know it's 100 nodes, so you're now knowing that you just spend $50 a month with that one line of code, you're going to be thinking every time, should I write this? Is this useful? Is this a worthwhile metric to send? And you'll probably err a few too many times on not doing it. And so if you're not going to track the things that could have been helpful, we're all shooting ourselves in the foot. So that's why we care about keeping the cost down. Great. So the talk had two parts in it. One is how to send as many metrics as you can. The other one is with as little developer overhead as possible. Let's go through that real quick. Adding stats to applications is extra work for devs, and you might not always be able to motivate them. And maybe for the language you use, your integration isn't very good yet. It shouldn't stop you from doing that, because if you even get the insight that something is wrong, it's still better than not knowing anything at all. You might not have the root cause, but at least you have something. And so I'm going to go through a few things that we released as open source that you could use to make this happen. Number one, Apache. We use it for all of our static content, which means all of the beacons, all the analytics we do is just static content. There's no dynamic servers behind Apache for us to use. Could emit metrics, so we had to write our own. So we wrote mod statsd, which is an Apache module that captures the relevant metrics directly from the request. And sorry, the GitHub project is linked from right there, as well as the documentation. And this is what you do. You turn statsd on. You pick a prefix, so you can uniquely identify it inside of Graphite. And then when somebody goes to localhost API/foo, ID is 42, the stat that comes out is Apache because of the prefix, api.foo because of the path. It's a get. It returned 200 in 31 milliseconds. Free. Adds about 20 microseconds per request. We're serving billions and billions of requests this way. The graphs that I showed you earlier come from this. Varnish, we did the same thing. All of our dynamic content is behind Varnish. So there's a libvmod statsd, which basically works exactly the same way. And we found less than 0.5% CPU increase by using that. Again, it's serving billion requests a day at Krux and other companies. This is roughly what it would look like. You import the statsd module. You import the timers. It's a little bit of pseudocode. But in VCL deliver, you just say, this is the backend you hit. Was it a hit or a miss? What was the response code, and how long did it take? And now every backend that is fronted by Varnish, you'll have those basic stats. Remember this graph? That's all Varnish. That is not actually an instrumented service. It just comes directly from Varnish. So any dynamic service we have, we just put it behind Varnish. We get these stats. Python. You probably use a programming language of sorts. We use Java and Python. We have a Python implementation of what we like to call our standard library. So that implements all the statistics, logging, and monitoring support that we care about as operators. So it's on PyPy. We released it as open source. Pip install Krux standard lib, and you'll get it. Our main design goal here was to make it really easy for devs to do the right thing. So you just inherit from a Krux application, and you'll get all the tools and instrumentation you need to build a CLI app that runs really well with monitoring, logging, and stats enabled. We make some opinionated choices, but we think it's a pretty good pattern to follow. And we release this open source. So the documentation is at the far bottom there. An empty sample app would do this. You get log levels, which then go to places that you would expect them, which makes them really good to run under, say, supervisor or in a D or anything like that. Goes to places you'd expect them to. With a --stats flag, you turn it on, and it starts streaming stats. In development mode, it'll use a dummy client, which means you won't be polluting any of our systems. Because of this standardization, it integrates really well with config management systems. So anytime that you deploy an app built on Krux standard lib, you as an operator know exactly how to turn on stats, how to configure monitoring. It's the same, it's the same, it's the same, which actually in config management places is great. Standard inheritance, it's just you inherit from our app. You have to give it a name. The name identifies the stat that it comes from, and it identifies it as a log line. And then you just do whatever you want. You get a logger object, you get a CLI parser object, you get a stats object, and you go from there. We built a few libraries on top of this as well for interacting with Bodo, which is Python's AWS client, so get all that nicely wrapped. Redis, which we interact with a lot, so we want to know, is it slow, is it fast, did it respond, were there problems? Again, all instrumented and logged. And AP Scheduler, which we hand to folks to do cron-like jobs for long-running processes. If you can't do that, at the very least, you can probably do something like this. Echo events.deploy.appname, and then send it off to localhost 8125. That's how those deploy lines showed up. Even if your app isn't instrumented, you can probably do a shell one-liner. In the worst case, you just send this one little UDP app off, UDP packet off, and you get those vertical lines. JavaScript. That's the one thing that probably doesn't work. We have a little stats app that we wrote in Python. In the query string, you send the apps you want, stats you want, and we send them async off as part of the app. So even our JavaScript is instrumented this way. We just do an async call somewhere at the bottom of the page and go like, hey, I found this stuff on this page. We get the same graphs. With 0 seconds left, I figured I should at least talk about Puppet since we're at PuppetConf here. Turns out you don't actually have to have a dynamic service. Puppet has tons of useful stats as well that come out of its reports. So we have a Puppet reporting module that takes the reports and takes the timing for resources, the errors, and so on, and sends that off to Graphite as well. So we can track our, say, Puppet runs together with events that happen or latency. So like, Puppet just ran here, and now the latency went up. Well, Puppet probably changed something. We should go look at that. 15 seconds over. Can I take questions, or should I just go stand over there for questions? I can take questions. Awesome. Person in the back, please.
So you mentioned backing up. I'm kind of the backup guy where I work.
You're the backup guy.
Yeah.
Who's the primary guy?
So the duplicity job very happily grabbed all the files, and we tried to grab them a little bit later, and of course they were all completely broken because I did not understand what WhisperDB was all about.
Mm-hmm.
How do you do that?
How do we back up the WhisperDB?
Yeah, well, not just individual files, but there's a whole lot of them. So the backup job is not like this atomic thing. You know, it's going to take many, many minutes, which is just ages.
Yeah, so the question is, if you run duplicity, which we do, how do you back up these tons and tons of files because they run for a long time? It turns out to be true. So we do a full backup weekly in when we know that almost nobody globally is awake to care enough about our services being impacted, which turns out to be Saturdays. And then we do incremental backups at our biggest trough in traffic, which frees up enough CPU and enough IOPS because we use pretty big boxes for Graphite to actually make that happen. Looking at you, Paul, have we actually run into any duplicity backup problems?
Yeah, I'm sorry, I don't know the magic that we use. I do know that we back up and restore successfully, but I don't know off the top of my head.
We don't have the magic at top of head, but we have restored from it many, many times, and it's fine. If you buy that fine gentleman a drink later, I'm sure he'll be very happy to talk to you about it.
Very good, thank you.
Any other questions? Sir? What is my company's position on big data? We think big data is here to stay, and we also think it's a buzzword. We obviously do a lot with data. We stream process quite a bit of it, which I didn't talk about here. We MapReduce a whole big chunk of it as well. And the hardest part about big data, it's actually not the individual size and individual chunk of data, it's tons and tons of little bits of data. Like for all those page views that I was telling you about, we get 2K of data in, maybe, but it's 2K of highly dense data, and we want to slice and dice that in real time. So what we found was the biggest problem is like, how can you look at that quickly, send off the relevant stats, and then process it onwards? That was part of the challenge here, and that's how we implemented it. You can buy me a drink later, and we can chat more about big data. Yes? Do we do any real-time monitoring? Yes, all of our monitoring is real-time. How do you mean not real-time monitoring? Yeah, so by the time that the data gets into Graphite, you're a couple minutes on. How do you deal with that? Fibbed a little. We care about some things in terms of trending and latency going in the wrong way, but actually we instrument all of our services to have a specific HTTP endpoint that monitors itself, and our monitoring jobs look at the HTTP endpoint of the service and ask it how it is doing, and if it finds the latency trending up, it immediately alerts, so we bypass that whole chain. Does that answer your question? Cool. Any other questions? Sir?
So what do you use for your alerting backend?
Alerting backend, a bunch of Python code that we wrote. We are not big fans of centralized monitoring. Most of the failures we've seen is centralized monitoring going wrong. And we rely very heavily on PagerDuty to do deduping of keys for us and keeping the state. So when we see something going wrong, we construct our PagerDuty key carefully and then let PagerDuty know. And PagerDuty has never let us down. So if you're not using PagerDuty, go there. Any other questions? Yes, please.
The Graphite data retention policies that you set,
Mm-hmm.
how do those roll up? Is it an average? Is it median, mode? Can you set that, or is it default?
How do the Graphite data retention policies roll up? There's a different configuration file that I didn't have time to go into called aggregation schema.conf, I want to say, that tells it when it does the aggregation, how it should do it. So like if it has a bunch of values, you should keep the maximum value, the minimum value, the average value, the summed value, and so on. You can dial all the knobs. The documentation is pretty good, but very expansive, so you'll have to take your time looking through it. If you're particularly curious what we do, I'm happy to look it up afterwards. Any other questions? Going once? Going twice? Yes.
Kind of in the spirit of this, I'm curious, with all this monitoring you do you auto-scale at all?
Do we auto-scale at all? No, we do not. Turns out that our traffic pattern is very, very predictable. And Amazon has a very good policy on reserved instances. We've done the math on it, and it turns out that for us to just preemptively buy the capacity or reserve the capacity needed for our peak plus a little bit is more efficient than us tearing down machines, building them back up again, tearing them down, building them back up again. Because we do have to run Puppet. There's a bunch of metrics that we then have. It's a bit of a waste. It's overhead timing cycle. And if such a news event happens, Autoscaler and ELB actually cannot keep up. And so we actually have preset ELB limits pre-configured with Amazon so they know that even though usually they only have the capacity this much more, in our case they have this much more capacity because we'll do this much faster than they can keep up. So in all cases, auto-scaling is just not fast enough, not on the Amazon side and on our side. And it's not even economic, so no, we don't. Any other questions? Yes, please.
Quick one. Do you know how many metrics per second can a single Graphite instance handle?
How many metrics per second can a single Graphite instance handle? If you use the setup that we use on a high one 4x large in Amazon, which is a box with a lot of CPUs, about, say, 64 gigs of memory and 2 terabytes of SSDs, we cap out at 1.2 million metrics per second. If you then split out the relay and the aggregator to its own CPU-intensive boxes and just do the storage, you can probably get to about 3 million, roughly. You'll cut me off when I'm supposed to stop, right?
Yep, it's just the party after this.
Yeah, if you guys don't care about cocktails, I'm here all night. Go ahead.
How many people do you need, or how much time is needed in order to support your metric environment?
How many people do we need to support that metric environment? We set this up when we were 3 people, and when it was done, it was done. It takes very little work to operate it. It took us probably about a week or 2 to get a good system running, and then 2 to 3 days worth of chunks throughout time to get it to the point where it was optimized like this. So hopefully with some of the stuff that we showed you, you can get rid of all that other work. The painful side is that the Puppet modules for Graphite aren't great, although I'm happy to share what I have with you if that's helpful to you. And that making the choices on how to configure Graphite requires you to understand it. And so that's probably where the biggest time sink is going to be. Once it's running, it's basically good to go. Any other questions? Sir.
RD versus Cassandra or some of the other database technology. I mean, did you look at the other approaches to that?
Was it RD versus Cassandra and so on?
Robin versus some of the other.
Did we look at that? We did not look at anything else because RD came with Graphite. It looked to work. And once we figured out that IOPS was going to be constrained and we wanted to try it on an SSD box, that problem just went away. So there was nothing specifically in Cassandra that would have saved us from the CPU contention that turned out to be the scaling problem. Sir?
Are you using the Instance Store SSDs or like EBS?
Do we use Instance Store or EBS? Ooh, we're being recorded. We use Instance Store for many reasons that I think are very smart reasons. I'm happy to tell you about them offline. The biggest problem with EBS is that you go over the network. And the main outages that we've seen in Amazon have either been on their SAN tier, EBS, or on their network tier. So we really don't like going off box if we don't have to. And if I wanted to get the IOPS capacity, I would be paying Amazon a lot of money. Any other questions? Who would like to go for cocktails? Sweet. Thank you so much for coming, guys.